Yeah, this is the final video of the year. In the previous couple lessons, we've been talking about surface area and volume. We've been talking about the ratios between surface areas and volumes for similar 3D figures. In the last lesson, we were using some of the surface area and volume formulas to help us find missing dimensions from a 3D figure. And now we're actually just going to go ahead and calculate the surface area and volume using those formulas. So a lot of what we are doing is just plugging values in and using the calculator to make a calculation. And I've just put some dimensions here on the formula sheet, so if you want to do that, you can. And I just want to talk about some of the maybe trickier parts of calculating these surface areas and volumes. So I will start with let's see, I will start with getting my pen, and I will start with the cylinder. So a cylinder has a volume, of course. It has a lateral area. It's that sort of space there between the top and the bottom. The tops and the bottoms are called bases. They're circles, and so they have a radius, and we have a height. So in this example, I'm giving you the height. That distance between the two bases is 12, and the radius is 4. So you can see that for all of these formulas, that's all you need is the radius and the distance between the two circles. Again, we have volume, we have lateral area. That's the surface area minus the two circles, and then the surface area is the lateral area, that 2 pi r h, plus the area of the two circles. Let's see if I have this right. Yep. And it's important to note the relationship between diameter and radius. Sometimes you might be given the diameter of the circle, and the diameter is twice as big if you don't remember from our discussion about circles earlier. A sphere is pretty similar. All we need is the radius. If we're given the diameter is 2 times the radius, so we can cut that in half. So the diameter of this sphere is 16 since the radius is 8. And that's all we need to plug in to find the volume of the sphere and the surface area. So a lot of this is just plugging into Desmos. And just for the record, I think I said it in the last lesson, when you are plugging into Desmos, if you type pi, it will turn into the pi symbol, and it will make that calculation for you. So for example, if I'm calculating the volume, I can do 4 over 3 pi, and it will turn into pi, and then I can do my radius, 8 to the 3rd power, and then it's going to tell me what the volume of my sphere is. Something new with a cone is we have a couple sort of height dimensions. We have one vertical height dimension, that's h, and then we have this slant height, which we talked about in the previous lesson. That's labeled with an L for slant height. I usually do it as sort of a cursive curly L. And then we have a radius. So again, we have a lateral area. It's this sort of like triangular bit, minus the base, which is a circle, again, just like a cylinder. And then we have the surface area, which is that lateral area, that pi rl, plus the area of the circle, pi r squared. Another letter here that we're introducing is capital B. I sometimes refer to it as big B. That is the area of the base. So capital B is the area of the base, and that's for any of these where you see capital B. You can see it to the left in the triangular pyramid. It's the area of the base of that 3D figure. In this case, the area of the base is the area of a circle, which we talked about in the previous unit, is pi times the radius squared. If you don't remember that, very conveniently, the formulas for area of a circle are on the formula sheet. Same thing with the area of a triangle, the area of a rectangle, and then some other shapes which we probably won't need to worry about. So if I wanted to find big B, since I have H, R, and L, but I need big B, I can find the area of that circle. So I have the radius, I plug it in here, I can do 3 squared times pi, and I'm going to get the area of the base. I just left it as 9 pi for now, but when we are calculating these volumes and surface areas, we can actually, like I said, type in pi and actually calculate that through. Different from what we did in the previous unit. We have a couple types of pyramids. I'm just going to talk about the square pyramid. It has a base that is a square. That's why we call it a square pyramid. It's that square. It has a lateral area again. It's sort of 4 triangles along the front, sides, and back. And then it has a base of a square. So when you see big B here, big B is the area of a square or a rectangle. This could be a rectangular pyramid. Again, you can go ahead and find those formulas there. And then we'll introduce a new letter, which is lowercase p. So we know the height of this pyramid straight up and down. We know the slant height. It has a slant height like a cone. L, we're given that here. And then I'm giving you the length of one of these sides here is 9. And so little p is the perimeter of that rectangle or that square. In this case, it's a square. I made it a square, so all of the sides of that base, that's not really square, but are 9. The perimeter is the distance around, so I add those sides together to get the perimeter to be 36. Capital B is the area of that base. Again, if you go up here, the area is length times width. That's, in this case, 9 times 9. And so capital B for this square pyramid is 81. And so now I have all the values, and that means I can calculate the volume, the lateral area, and the surface area. I think up here I have my rectangular prism. It has a length, a width, and a height. Depending on how this prism is laying, the length, width, and height, it doesn't matter which is which. Once we have all those, we're able to calculate the volume and the surface area using those 3 dimensions. For my triangular prism, again, I have little p, perimeter of the base. This time it's a triangle. There is no specific formula for perimeter for a triangle. You just add up the 3 sides. The formula for big B, which is the area of a triangle, is what we would need from here. So we are going to have little b, which is the base of that triangle, and then h. And it's important to note that these are perpendicular, so the height is making a 90-degree angle with the base. And so there I've documented my height of the prism. I found the perimeter of my prism by doing 3 and 4 and 5 added together. And then I can find the area of my base, which is this triangle. I believe the way I have it set up is a right triangle. So I'm going to multiply 3 times 4 and then multiply by 1/2 from this formula up here to find the area of that triangular base to be 6. So again, once we have all of the letters of value assigned to them, whether it's from the picture, or you find the perimeter, or you find the area of the base, then we can just plug in and find all of these other measurements: volume, lateral area, surface area. So as always, if you have any questions about this, please do ask. I didn't do any of them in the calculator because I am confident that you can take these values and plug them into the calculator to get a right answer. If you do need a little help, as always, ask. You might test some of these out, use some of the values to find the volumes or the surface areas of these figures that I've talked about. But if not, you can go on to the practice. And as always, take your time.